Hi everyone. We're going to go over the code we were looking at last time with File.io. I finally got Visual Studio working again, although it still says I'm generating viruses with my exe in case anyone has something similar. But I looked online, did a lot of research, and it should be perfectly safe in this case to ignore. Just in case you're wondering and you're concerned about my how I'm doing. Anyways, I wanted to show you an example of using printf. You can also even do a scanf. So let's scanf underscore s, and we'll put in, I'm going to do two different things. I'm going to make myself a buffer here. So buff1, and that's going to be size 40. And I'm going to use scanf just to give another example of how this actually works. So scanf underscore s is going to take whatever I put in here. It would normally be something like a string. And let's also do another one of these. Int my test. Okay. And I'm going to put a buff1 in here. And normally scanf just by itself, I wouldn't have any other parameters going in. But in this case, I'm going to say 39. Now I could use 40. I think 40 is probably still safe. But just on the off chance that I want to make sure I have a space at the end, like that 0 at the end. So I'm going to make it 39. Now, the smarter thing, though, would be to have defined this as some actually variable. So let's fix that then. Constant int buff size is equal to 40. And I'm going to put buff size here. And so if I change it to 80, let's say I just change buff size. So I change it to one place. I'm also going to do the same thing down here. I did the same thing. And we'll look at that in a second. So this thing is going to take something from the input from the user and stick it into this string right here, a buff, or the character array where I'm going to store my string. I'm also going to do the same thing again because I'm lazy, and I'm going to use an integer. D would be the traditional way of doing it for digit. I don't remember, and I always think double. So technically, because I have a single variable, I don't need the size of the array, although I can put it in there. So let's put that in there. And the one other thing I need, because if I try this, it's going to blow up my face. I need to explicitly say what we're going to find out is me indicating that this is a pointer. That's what I need in this particular case. So let's save this, and let's make a couple other printf statements. Printf, write string less than I'm not sure if the less than symbol is actually going to work. Let's find out. Why not? Characters, and this is going to be buff size -1. And then I'm going to have printf write add int to save. All right. Notice I can put a parameter in my string here. So here's a string that's going to output, but as soon as it gets to one of these things, it says, okay, what's the first parameter? Okay, well, I get to another like a %s here. Okay, what's the second parameter? What's the third parameter? It just goes in order. That's all we're doing, just to remind you. All right, let's compile this. That scanf is not happy with me right now. Power not used by the format string. Okay. I actually don't technically need that because it's a digit. So it should hopefully still work. We'll find out. It's supposed to not yell at me on that one. No, it's going to cancel this. And let's put a breakpoint just to be on the safe side. Let's find out. Okay, first of all, we're going to look at There we go. That should break things nicely. Notice this will take a string. Only a string up to a white space. So hello, how are you? All one word. And as soon as I get to that new space I put afterwards, the end is going to be going into that integer scanf statement. That's going to be a potential problem. So let's see if it actually blows up in my face. It didn't, but my test is equal to some crazy number. In fact, this should scanf underscore s should return something like the number of characters I output. This is probably the original value I had, and as if it doesn't work correctly, because, well, it's not the correct value, then I'm assuming that this is actually going to, I'm going to watch, so add to watch, and I'm going to make this a hex value. There you go, uninitialized. That was the problem. So that's what we're getting here. It's trying to save that next word, and it goes, oh, that's not a number, and just bails. Doesn't set the value at all. So let's fix this up properly. With no spaces. All right, let's compile it again. So turns out if I put anything other than an integer in here, it just essentially it ignores it, and my test doesn't get set to anything. So you might imagine it might be a good idea to set my test to being some default value, just in case. No, this is just my Google Drive messing things up. Here we go. So, hello, how are you there today? All right. I'm going to wait for an input. Hello, how are you there today? That works. If I had it more than 40 characters, it's going to presumably cause an assertion failure, or the other option, it doesn't set a buff1 at all. If it's beyond the size of this, it could do different things depending on the compiler. Yeah. So if something goes wrong, you normally have to be defensive about it and just make sure things worked out well. For example, you can find out what scanf underscore s, it should return, I do believe, an integer saying how many characters it read. If it's greater than 0, well, then you know it worked out okay. Okay, so let's see if I can go down to the next line. Continue. Okay, right, and into save, and let's write it into save. So 43. All right, and then the rest of my code goes through. Fine. So here's me using scanf for saving an integer. Here's me using scanf for a string. Notice this weird thing about strings. With a string, I don't have to put this ampersand right in front of it. We will see why very, very shortly when we're looking at pointers and we're looking at memory, and we've already talked about the fact that character array is pointing to the front of the array. That's the difference. This is a pointer to the integer. I'm pointing to where the integer is stored. This already is doing it. It's pointing to where the array is. We'll look at pointers very, very shortly. Okay. Next step, let's change some stuff around. So, let's also look at a couple things here. I was playing with this, so I'm going to output two numbers, one after the other, with 10 spacing is in between. It's going to be, I do believe, left aligned, and if it's positive or negative, it'll be indicated there. So let's put a negative in here, positive in there, negative in there, positive in there. So, well, let's bail on this. Let's get rid of that plus and see what happens. There you go. That'll tell us what that plus does. But I said there's a lot of different flags you can put in there. So, for example, in this case, it's going to be 10 spaces are reserved for the number being put in, and I will put in a bunch of blank spaces in this case, to the left of what I'm to the right of what I'm looking at. This is left aligned. I'm going to have 10 spaces in total. Then I'm going to put the word spacing. Then I'm going to do the same thing. Well, this time with a let's remove that one too. The same left aligned, 10 spaces, putting in a number. The same number, 10. 10 spaces, it means I'm going to have 8 blank spaces, and then I have the 2 characters. Or I think the negative sign or the positive sign will not count for 1. So I should have 7. So 1, 2, 3, 4, 5, 6, and then the rest. The rest of the 7 characters are white space, are blank space. I'm always obsessively compiling just in case. All right, let's have a look. So I have 10 characters, spacing. Notice it's perfectly aligned here. This is 10 versus this big number, and yet the amount of space I have between these two, before I get to the word spacing, is exactly the same, because I said I'm reserving 10 spaces for characters. If I didn't have that, it's going to look very different. Notice it's also left aligned. Let's check out what happens, and because I added the plus in there on the next line, whether it's plus or negative, if either it's positive or negative, I still will indicate the sign. Otherwise, by default, it'll only indicate the sign if it's a negative number. Okay, one more time. Instead of 10, let's figure out, well, instead of this left align, let's get rid of that and see what happens. Half of the fun of doing that, well, you may not think it's fun. Half of what you do is just like, I don't know what it does, let's try it out. I mean, it doesn't really hurt. There you go. It's right aligned. Notice the word spacing, still aligned. I have right aligned text on this line, left aligned text on this line. Same number, that's 10 characters. So left aligned versus right aligned with the dash. Okay. I'm not going to ask you to memorize all that. I'm just saying there is a slew of documentation on what all of these various things mean. So if I have this, it means one thing. If I do this, it means another thing. Or let's take one more. If I put a 0 in there, this will mean I will prepend all the numbers. If I have the number 10 and it's 4 digits long, so from 9,999 down to 0. If the number I'm representing is 10, I will have 0, 0, 0, 0, 10. Right? I will put the implicit zeros in there. That's what that thing does. Then it says I'm going to use 8 characters. I'm going to have 8 characters in total. So I'm going to put in the blank zeros. There's going to be 8 characters in total, and after the decimal point, I want you to give me 2 numbers after the decimal point. That's what this thing is saying, and it's a floating point number. So floating point number, 2 numbers after the decimal, 8 numbers in total, and if it's the zeros, the implicit zeros before the number, put them in. So what I would expect is a bunch of zeros, 10.3, and this should be 5. It'll round. Let's see it in action. All right. So 1, 2, 3, 4, 5, 6, 7, 8. 8 characters in total. 2 at the back, preceded by zeros that I need to have essentially filler zeros at the front. Okay. So that's printf and some of the weird quirky things you can do with printf. Again, not going to ask you to memorize that for an exam. You can play around with it, and it's useful for an assignment to make it look pretty, but you're not going to be asked to, like, what's the syntax for finding out how to put all zeros at the front? Let's look at reading and writing to a file. We've briefly looked at this. I'll go over this again, and then we'll look at it in the slides a bit. So here's what I'm going to have. I have a file stream. I'm going to make a file stream, my file. I'm going to make a pointer to my file. That's all it's doing. It says, hey, where's my file? Wherever my file is stored, That's the address I want to keep around. So this is a pointer to my file. I normally go over this file IO after we do pointers and memory and a bunch of other things, but I wanted to have it for the assignment. So what you need to know is I have my file, I put an and in front of it. That's then I can say it's a file star. It's a pointer to my file. That p underscore is just saying it's a pointer. This is my convention, or a lot of other people's, some people's convention, to say what kind of data we're looking at. It's a pointer to a file. So a pointer to my file. Here is the name of the file that I'm going to use, and I could do things like, let's see if this is going to work. We'll find out. We're going to read in, so this is the file I'm going to open. It's a relative file path. If I left it off, by the way, it's doing the same thing. It's looking at the current directory. Okay. First step, I'm going to open my file. When I open my file, I pass a pointer to, with file open underscore s at least, I pass a pointer to my pointer. That's what the underscore s is forcing me to do. If I had f open, I didn't have this particular issue. I just passed in my pointer and it spit back out a pointer. Because just how the more secure version of file open works, I need to pass a pointer to my pointer. Okay, here is the file path name. So this is the name of the file itself, and something to slow it down, everything. All right, so here's the name of the file itself, and I'm saying I'm reading. The R for read. And guess what the write would be? Oh yeah, it's a W, right? It's fairly intuitive. So we'll be only dealing with reading and writing. When I'm reading to a file, from a file, I'll use an R. If the file doesn't exist, it'll let me know. What the weird thing here is if I try to read from the file and it doesn't work, this thing will then be null. So if the file doesn't exist, then so let's put it, I'll do that in a second. I'll put a 2 there just to break everything. And I'm also going to get rid of this scanf printf thing, because I don't want to have to write that every single time when I'm testing my code. No, I don't want to do that. There we go. Must have accidentally saved. Okay. So if the file exists, then I'm not going to go into this condition. So let's say is equal to null. That's easier, hopefully, to read. But that's essentially what we did before. Null happens to be, when we look at null, null is the value 0. So if the pointer is equal to 0, it means it's not pointing at anything. It's just sort of pointing up in the air. If it's pointing to nothing at all, I'm done. The file didn't open properly. And I need some kind of message to say, hey, by the way, the file wasn't found. Fix that. So here's my, if things don't go well, do this. All right, and I just get out. After that, I am going to, what I decided to do here is I've opened the file. I'm going to read in using fscanf underscore s, of course. I'm going to read in each token in my file. So each part separated by spaces. Here's what the file looks like. Okay. So if I'm going to read in each part separated by spaces, that's what fscanf will do. So I'm going to read in from the file. It's going to go into a string. Here is the character array that I'm going to store this value in. There's the maximum size I can write in there. And if things go according to plan, then fine. If things don't go according to plan, or I get the end of the file, then I'm going to stop, essentially. When I get to the end of the file, I'll stop. Otherwise, I just keep on pulling off each individual part. And then I'm just going to say read section and then the string I just read off. So what I would expect to have is something that looks like this. All right. Let's run it again and see what happens. All right. So I'm going to, let's see what happens. File not found. Oh, it didn't find the file. Oh, there we go. // it was looking for /m, which is not what we were looking for. Yeah, that was a syntax error on my part. Unreferred local variable. Where is that? This is not being used at all by anything. Okay, that's fine. Compile it again. Okay, it read the file correctly. It read in section myfiletest.txt, this number, myfiletext.txt, this number, myfile so each of the lines that I have, and then it gets to the end of the file. When I get to the end of the file, the fscanf return value is some constant called EOF, end of file. It's actually equal to -1. We'll look at defines, the precompile instructions, precompiler instructions later on, but EOF is end of file. It's -1. Okay. So when I get to the end of the file, stop. This is me reading in each little token in there. But let's change things around, just for fun. I know, so much fun. I'm going to comment this whole chunk out until later. And here we go. Here is me. Here am I. Here is me. Here am I using, I'm going to write to the file. In fact, I'm going to use the same file. I'm going to write to this file. What's going to happen? So let's take a quick look at this. This is what the file looks like. Whether I succeed or not, if I open the file and start writing to it, I will wipe out the old version of the file. Just be very clear about this. If I write to my file, I will wipe it out. Meaning, if you want to make sure you don't wipe it out, save it to a different file and then transfer it over, change the name later, right? But what I don't like doing is reading from the file and then writing to the same file immediately, because there's always a possibility that my write is wrong, doing things wrong. I have a bug in my code somewhere, and I wiped out some of the work I did earlier. So I want to change things around. I want to, instead of this tab, this is actually a tab delimited file. Let's put a comma in its place. Okay, we're going to see something very different after I run this. So it'll be the file path, comma, and then this number afterwards. That's commas in between. So I open a file in write mode. If the file doesn't exist, get out. Okay. Then I'm going to print to the file using fprintf, one line after another, 3 times, so 3 lines. And then always, when I'm done with a file, I close it. I only close it, by the way, if it opened. Notice I don't have a fclose here. It never opened properly. But this should still work. I'm wondering if you guys want to do, I'll see us wipe out the file. Okay. Hopefully it's gonna let us do it. Just be going slow. There we go. That same bug I've been getting in 2400. No clue what's going on with that. But let's look at my text file. It's changed. I've changed my text file. Great. Well, maybe not great, but I've changed my text file. It now has commas in between instead of a tab. A comma is not whitespace, obviously. So what we would expect is that my way of processing what I did earlier, this thing up here, is different now. It's not going to work the way I expected it to. So let's block off that again. The files should now all be very different. And instead of having 6 different times through this loop like I had before, I'm going to have 3. 1 for each line. So let's compile it. I'm expecting to see each one of those fscanf underscore s is to pull off the full line. Okay? See? 1, 2, 3. Here's the problem with using fscanf. If I wanted comma delimited files, what we're going to talk about, or already did, I think, in the last lecture, is if I want to show, just say 3 or 4 fields per line. So I have 3 or 4 different fields, let's say 4 fields on a line, and each row has 4 fields, and therefore I can actually represent like a table of values. That's actually what Excel saves your values as, if you save it as a comma separated value file. In fact, that's what I export out of CU Learn. When I grab your grades and I'm doing all the analysis and figuring out what your final grades are, I get a comma separated value file from CU Learn. It is so common that you may not even realize you're doing it. Tab delimited, comma separated, same thing. It just means, how do I tell the space between these fields? I put something special in there, a special character, like a comma, like a tab, like a tilde if I wanted to. What I don't want is a space, because here's what happens when I accidentally put, looks about the same, right? Let's see it in action. 1, 2, 3, 4. fscanf stops whenever it gets any white space, whether that's a space, an accidental space, whether that's I have a whole bunch of words in the English language, one after the other, and I want them to as one string. It doesn't matter. Scanf or fscanf, both of them just go to the next white space. And if it's a comma separating these things, doesn't count for white space. If I accidentally put spaces in there, it counts as white space and breaks up my file when I don't want it to. It's way too easy to put spaces in a file, and users will just randomly put spaces in your file. The general principle is just don't ever delimit based on spaces. It's way too error prone. So what can we do instead? We have it doing a space. Let's try one other thing instead of. So I'm going to comment out this part here. So I'm opening the file. I'm going to get. Okay, so this is my while loop here. I want to figure out what the syntax here is. So f get s underscore s. Okay, the safe version of f get. I don't know if I have a caps lock in here, but p my file, and then what am I doing with my file? I'm going to open. I have my file. I'm going to put it in a out buff. I'm going to say the size of my buffer. This is the syntax for fgetS. It's getting a string from a file, fgetS, and safely doing so, underscore s. Okay, so here is, let's double check that is undefined. Let's see what happened. Why the heck is that undefined? Okay, character buffer, max count, that's where it goes in the middle. It's the character buffer first, then it's the file. Okay. And I don't think I had a safe version of it. I just fgetS. Okay, live and learn. Let's double check. Okay, takes in a character buffer as the number of the maximum count, and I'm going to get it from file stream. It's going to return a character pointer. What I would expect this character pointer to be is null when I can't pull anything more off. So let's hope this is going to work. Does not equal null. So as long as I'm able to grab another chunk. Oh, I don't want that. Okay. I grab a line of text. It will also return a pointer to that text. Or if that text, there's no text to be pulled off from it, it'll return null. That's what fgetS will do. So hopefully it's going to work. We're going to find out the hard way. It should get line, 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 and then it'll be null, and then I'll stop. And you're probably wondering, what's the difference, or why would we want to do this? Hopefully it's not gonna, oh, there you go. Notice whether there's spaces or not, it will read in the entire line up onto the carriage return. It'll read the entire line until the new line. What's important about this is once I've done that, now I can play with the text in some other way. So there's a bunch of different ways you can do it. You can use, there's some ways of scanning through text and using particular delimiters. There's using scanf and then trying to, I think scanf only does it for white space. So commas, it doesn't handle for things for commas. What my natural instinct would be is to grab, or what I always do, is I grab the entire line. If I'm using commas as delimiters, I'll grab the entire line and then parse it myself. So what I could do now is I could use my strchr function to say where the heck that this right here is. For example, find the location of where that comma is, and then use that to find out where the next character is. So here's what I'm going to do. I'm going to say while, okay, so it's in a character buffer, while strchr, and it's going to be, this might be a little bit hairy on for our purposes, but the position of the comma, and I'm going to point it to the front of my array. At the end of all these loops, I'm going to print that array. Great. P, comma, pause. So I am looking for, in this string, I'm looking for comma in the string. This thing is going to return a pointer to where the comma is located. So what do I want to do? I would actually like to do this way. P, comma, pause is equal to this. So I'm locating where the first comma is, while P, comma, pause, while that is not equal to null, let's say, I'm going to keep on printing off these things. Or I could do a do while loop. Maybe that's better. While. Something's looking weird about this. Okay. Okay, here's my do while loop. In case you forgot what the heck these things look like. I could then put this inside. So I'm going to grab the first, I'm looking for the first, actually I'll look for the second comma. Do I want to look for the first comma or the second comma? This is where things will get a bit fun. What I'm trying to do here is go through this string, finding the commas. When I find a comma, do something with that information. For example, I might just get the string from this point to this point. Let's try and keep it a bit simpler though. Okay, I'm going to print off what was currently at where comma pause is located, just to see this in action. Okay, so what it's going to do is it's going to find each of the commas. Every time it finds a comma, it's going to print off the rest of the string afterwards. Okay, and since I grab the entire line, I can do all the little tricks we're going to have with strings, with C strings, for finding a character, finding a string, delimiting based off of certain things, finding the string length, things like that. Okay, I don't need that anymore. And if I can't find a comma anymore, then this thing will stop. So I'm not going to return the last of those entries, presumably. Let me see here. It'll print it. It'll print the next one. It'll print everything properly. Let's have a look at this. So what should happen is I should get a new line for every single one of these commas. Oh, and I have an infinite loop in here. Oop, okay. So the comma pause, it's not finding that. We're like, oh, I know why it is. I keep on finding the very first comma. I'm at the comma, and then I find it again, which is exactly where I'm pointing. So one position over is the way you would do that. Exception, something going on here. My comma pause is equal to null. And why would it be? It's not finding. Well, it's not equal to null. P comma pause is equal to out buffer. I'm gonna have to breakpoint on this thing. Okay, so P comma pause is equal to this thing here, right? It's going to find the next comma. Should be next comma. Okay, it's going to find where comma pause is again, where that number here is. It's then going to, while P comma pause is not equal to null, it's going to loop around. It's going to output this value here. It's then going to find the next comma position. P comma pause is equal to null. While P comma pause is not equal to null, fail on this. And that's why. Okay. Anyone guess what happened? I get the first line, I find null at the end, and then I don't reset it afterwards, which is what I had to do here. That's what I should have been doing each and every time. All right. I'm going to reset the comma position. Okay. Let's remove my breakpoint. And let's run it. Boom. All right. So, original line, found the comma. Original line, found the comma. Original line, found the comma. One after the other. It's a comma delimited file. So there are times I might want to use a tab delimited file, for example, and I need to find where the location of these tabs are and pull off information. Or comma delimited, or tilde delimited, or whatever I want to use. I don't want to rely on spaces or white spaces if I have a format of a particular style. And we'll look at that right now. And again, after I'm done, I close my file. Okay. So we looked at this. We looked at opening a file. I want to do a couple more things. And we looked at relative versus absolute path. You'll notice that the file that I had in Visual Studio, it's just in the same directory as all my CPP files, and essentially that's where the working directory of Visual Studio is, for that project at least. My suggestion is, if you're trying to read from a file, do not write the rest of your code. Make sure you can find that file. It can be very frustrating trying to find out where the hell it's looking for that file, because it looks in weird places sometimes. So, like for example, if it's running from the command line, running from the console window, it'll look in a different directory than if you're running in Visual Studio. Just completely different directory. Fun. Okay, so the big thing here is if I try and write a file and it already exists, it'll erase the original file without any warnings. Like no warnings, it'll just wipe it out. We've seen that. You can keep the original, but most people, they put in a W, it wipes the original. If the file doesn't exist, it will make one. And if something goes wrong, it'll return null for the file pointer. So we'll get to pointers soon enough, very, very soon. But some of this will be on faith. So for opening a file, we open the file and then we do an if statement to see that it actually opened properly. That's always our first step. We never just assume it's going to work. Only then can you check or read part by part. So fgetS will read in an entire line, or fscanf will read in a chunk up to the next white space. And every time you call it, it moves it down. At the end, I want to close my file by passing the pointer to the file stream, the file stream structure. And you technically, you wouldn't have to officially close your files, but guess what? It's just like memory leaks that we're going to be looking at, or we already looked somewhat at. If I make a brand new dynamic array and I don't give it back to the system, I have a memory leak. If I don't close the file, other processes will not have access to that file anymore. Even my own program will not have access to that file anymore, or I get weird, corrupt files and the like. General principle or general rule, always, like picking up after yourself or cleaning your dishes, close your file, please. Okay. Why do we need to? Because, well, it keeps the system intact. It may not seem important, but if I get bigger and bigger code, it will come back to haunt you. So, much like, cleaning up your own dishes, you don't want to get ants. You clean up your dishes early. You don't want to learn the hard way why you have to clean dishes. Also, the file can be locked by the application, and so you might lose access to the file afterwards. It will give you an implicit closing when you finally close down your application, but don't rely on that, please. Okay, so here's an example of me using a file output. So I'm opening a file, area data.out. I am writing to the file. This would be me opening the file. This would be the safe version of opening the file. Notice it's a pointer to O file. This is just, I open it, I call area data out, and I get an O file. This is the old way of doing it. But then people did kind of silly things. So I'm going to get a couple of numbers. I'm going to calculate the area. I'm going to file print a big bunch of space. I could have actually said how much space I'm going to reserve in there, and the area. So I'm just going to output this particular area, and then I'm going to output the area for this is going to output the area value with a certain precision. So that should be 4 characters wide and 2 after the decimal point for 4.2f. And then I close the file afterwards. Yeah, simple. Okay, this is what I get. So if I open the file and I call area with a bunch of spaces, I get this big bunch of spaces here. Right here, that's this line here. Is on that first line. Notice the new line here. And then afterwards, I write eclipse, space, and then 4 digits after the with 2 digits after the decimal point. And it's going to output the area value. So while I try to read from the file, I normally will open the file, and while I keep on reading, I'll read bit by bit from the file until I find out at the end of the file, I try to read the data, and when I'm done, then I close everything up. fgetS will return a pointer to so fgetS will return a pointer, yes, I guess, and fscanf will return an integer. fscanf underscore s. Well, we'd have to look at our example again, and we can use a loop to just go get the next part of our file like we did. So here'd be another example. I'm going to, here's the file as 23, 45, 72, 245, 67, 235, 123, and I have this while loop that's just, do I have a field coming out? This is a number that I'm getting from this thing. fscanf will put something in that number, and then the returned value will be fields out here. It'll also be the value number. The same, they're going to be equivalent to each other, number and fields out. If fields out is greater than 0, let me see here. This is the number of, let me see here. it's getting a number. It's getting it from the first parameter from the file. Oh, I'm getting the number. No, I'm getting the number from the file. And the file pointer should be something else. Anyways, I'm going to move on and double check on this afterwards. But what I should have here is if the field out is greater than 0, so it's not it's not equal to 0, then so yes, this should be the number of fields it reads in, or the number of numbers it reads in. It'll always be 1. It'll be pulling off 1, 2. It's not the actual number. It's how many fields it reads in, how many fields it reads in, how many fields it reads in, or how many characters it reads in. In this case, it's always one number, unless there's no more numbers to read, in which case it'll be 0, and it'll stop. This whole loop will stop. So as long as I got a number in here, I'm going to print off that number with a spacing of 5 in the front. So notice they're perfectly aligned with each other, 5 spaces across. And the total number I've collected is going to be incremented by 1. So I have 6 numbers. Each time through the loop, that number is going to increase. And so at the end, I can print off the total number, and that's going to be 7. There's a spacing of 7, 6 white spaces, and then this number at the end. So my question to you, how many words are in this sentence, the sentence that you see there? Can you count them? I'm sure you can. There's 7. How do you know that? Well, because you've trained yourself. You trained yourself a lot since a very early age how to parse this thing. We do this every single damn day. Every time we read, we do this. We use white space to delimit where our words are in the English language. So every time you get to a white space, you think new word, and then you go to the next part. If it's hyphenated, you do something different. Sometimes you don't think of it as a new word, but it's still white space. But for the most part, unless there's really strange exceptions, every single time you see a white space, it's a new word. So I will count 1, 2, 3, 4, 5, 6, 7. And when I get to my punctuation, I know either a period, a question mark, an exclamation point. I know I'm at the end of my sentence. Done. That's how many I count. So my condition for stopping this thing, I would have a quote unquote a while loop where I pull off the next word, and every time I get a white space, I stop that word and pull off the next word after that white space, and the next word after that white space. And when I get to a piece of punctuation at the end, that's when I stop my sentence and I count the total number of words I've counted. This is a delimited piece of text. You do it all the time. But we can't rely on that. So I know the next field is after the white space, but if I put 2 white spaces in there, you still read this just fine. Computer, not as smart as you. Doesn't necessarily know. So what we want is some way of saying where the next field is. Like if I have a table of values, I want to know where the next field is, and the next field, and the next field. I want to be able to keep a whole bunch of numbers, or a whole bunch of different courses that you took, for example. And when I get to the end of the row, I want to know when I'm at the end of the row. Right? So I'm going to be using a carriage return, a new line, to indicate when I'm at the end of a row of values. And each field in that row, each column, if you will, is delimited, is separated by something. Something that we say, you save this for a special occasion. You don't put random tabs in a tab delimited file. They're there to indicate when the next field is. You do not put random commas in a comma delimited, comma separated value file or comma delimited file. You wouldn't know what to do with it, right? You need to make sure that the things separating your fields are consistent. So, classic comma separated value file would look like this, right? 1, 1, 2, 4, new line. Therefore, I'm on a new row. Tab delimited. I have tabs in between. And if I put spaces, bad things are going to happen because I could accidentally put a space here, maybe here, maybe here, maybe here. Spaces can go all sorts of places. People put them around willy-nilly. People are terrible for this. So if you put spaces in your file and you use that as a delimiter, it's going to be very, very error prone. So the two standard ones are tabs and commas to indicate when you're at the end of each field. Number of fields is typically the same between rows. You don't normally have a row with 4 fields and then a row with 3 fields and a row with 17 fields. It's always the same number of fields each time. And so each row, it's a table like in Excel, right? It's a table with a certain number of columns and a certain number of rows. That's what we are saving in one of these files. So this might be a tab. This might be a delimited file. I have a name, what they're drinking, and I guess how much money they're paying. What they're I don't know what the heck the 12 is supposed to be. Size, number of ounces. Sure. It should have some kind of regular structure. So I could put tabs in between Eric, Latte, and 12, and then I know exactly how many fields I have. 3. When I get to the character, that's the end of the line. And so I can store what each person wants, and I can actually use this later on to fill in my structures. I could take a tab delimited file, read in all the various parts, store it in a structure, and I'm good. It can be a little challenging to deal with, but that's why we can do a loop. We use fgetS, and we can parse this using the string functions that we have. Okay, so with that, that's what I want to talk about with file I/O. When we come back next time, we'll be looking at memory. We'll be looking at arrays a lot more. Okay, and we won't have to worry about like this hand wavy part of what that ampersand is doing. Right, what a pointer is. That'll be hopefully very clear very soon. Thanks everyone.